Hi everyone, Senan this side, and in this video we are going to solve this LeetCode daily problem, which is maximum score after applying K operations. So before we get started, I just want you guys to know that the whole solution PDF is provided in the description below, so be sure to check that out. And now let's get started. So the problem is maximal score after applying K operations. So you are given a 0 indexed integer array nums and an integer K. You have a starting score of 0. In one operation, I can choose any index I and I increase my score by nums of I, and after that I replace nums of I with this ceiling of nums of I by 3. Return the maximum possible score you can attain after applying exactly K operations, and this is the definition of the ceiling function. So now let us first of all look at this test case, and we have what? We have 5 tens and we have to return the maximum score, right? And K is equal to 5. So what I do is basically I can choose an index and choose a number and add that to my score. So score equal to, currently the score is 0. Now what I do is, let's say I choose this index, I increase my score by 10, right? And after that I update this value to seal of 10 by 3, which is what? 4. Similarly, since I've used 1K, I'll decrease this to 4, and then let's say I choose this one because we have to get the maximum value, right? So what I'll do is I'll try to choose the maximum element in the list. So I'll take this 10 and this would be 4, then take this 10 as well, this would be 4. I'll then take this 10 again, this would be 4. I'll take this 10 and then update. So in the end what I'll be left with is value 50, and where we had K equal to, and every other element in this would be 4, and that is how you get the value of the score. Now since we have to get the maximum possible score, what I want is at every instance, at every time interval, I want to have the maximum element from the list, and at the same time when I update an element, that should also be taken into consideration. For example, look at this test case. Initially I'll pick this 10 because this is the maximum element, and now after I update this by seal of 10 by 3, that would be 4. So in the next iteration I would again choose the same index, so I'll choose this again, the value 4, and I'll take that and then I'll update to 4 by 3, the seal of 4 by, which is 2. So I had taken 10, I had taken 4, and since K is 3, I can take one more value, so I'll take, let's say, this 3. So now I would have a total value of 17, and that is what I need to return. Now seeing this value K, you are sure that you have to use a heap, and that is what we are going to do. So let's look at the solution. So initially I declare a priority queue PQ, which is a max heap, and for every element in my list I push that to this priority queue. So I would have all the elements in my priority queue, and at the top of this priority queue I would have my maximum element. So let's declare a max score as 0, and for K operations, so we have to perform K operations, right? What I'll do is I'll take out the topmost element and store that as a double. Why? We'll see that later on. And I'll remove this from this heap because we have to update this number, right? Now what I do is I'll say max score is plus equal to current score. So I update the score with the maximum score that I can possibly have from the list. Now after that I push this value seal of current score by 3. So the reason I took this as double, so when I do this double by 3, the final answer would be in float, and to take that seal would be easier. And in the end I push that new value back to the priority. So I do this for K operations, so I would have the maximum score after the K operations, and I would return this max score. So that is the idea. What is the time and space complexity? So n elements and pushing takes n log n time. So n elements and log n time for push operation. So this would be n log n time, a time complexity. Now for this one, again pushing and popping. We are pushing, and first we are popping, then pushing. So when we are in this for loop, the size of the priority queue or the max heap is n, right? So I take the top one, I pop one and then push one, pop one and then push one. So the size of the priority queue is constant after every iteration. So popping and pushing will take your log n time, and this iteration goes for K times. So In total, this operation would take k log n time. So the total time complexity is n log n plus k log n, and the space complexity is what? The space is taken by this priority queue, so big O of n, because the size of we are storing every element in this priority. So yep, that was the video. I hope that you were able to understand this. Be sure to check the description for the solution link, and I'll see you in the next video.